When you buy like a high-end sound system for your living room, the biggest danger it usually faces is maybe somebody accidentally knocking over a glass of Pinot Noir or, dusty shelf.
Right, yeah. Dust is about the worst of it.
Exactly. Because you're working with a perfectly controlled environment for the listener. You've got 72 degrees, low humidity, complete physical stability.
And the acoustics are highly predictable, too. I mean, you have walls to bounce sound off of, soft furniture to absorb echoes.
Yeah, rug placement, all that.
Exactly. And you have a dedicated power outlet providing a steady 120 volts without breaking a sweat. It is basically an engineer's dream scenario.
But, and this is where it gets crazy, take that exact same expectation for acoustic perfection and try to replicate it while you are rocketing across the open ocean at 40 knots.
It's a completely different universe.
It really is. Suddenly, your cozy living room is being pounded by saltwater, ultraviolet radiation, and vibrations that would honestly just rattle a normal circuit board into dust.
Oh, absolute dust.
So, welcome to this custom-tailored deep dive, crafted specifically for you. Today, we are taking you into the surprisingly intense, incredibly complex world of premium marine entertainment systems. And specifically, we're looking at fusion marine radios.
Yeah, and to figure out how any of this is even possible, we are unpacking a brand new guide that just dropped today.
Today being June 29, 2026, just to set the timeline.
Right, exactly. And this guide is from Michael Rabilio. He's the founder and principal systems architect at Concord Marine Electronics down in Fort Lauderdale.
The yachting capital of the world.
Basically, yeah. And we're also layering in a huge stack of real-world customer reviews from their actual installations just to, ground this whole thing in reality.
Because theory is great, but the ocean doesn't really care about theory. So the mission for our deep dive today is to really deconstruct this for you. We want to figure out why putting an audio system on a boat is such a massive engineering challenge.
It really is an extreme environment.
And we're going to see how modern marine stereos have evolved from basically just being a waterproof box that plays AM/FM radio into what is essentially the digital central nervous system of a modern yacht. I really want to jump straight into the tech and how this actually survives out on the water.
Well, understanding the environment these systems operate in reveals why the integration matters just as much as the hardware itself. Robilio's source makes a massive point about the fundamental difference between marine and automotive stereos.
Right. Because people constantly try to cheat the system, don't they?
Oh, all the time. They try installing car speakers on their boat just to save a few bucks.
Which is like taking your pristine living room television to a saltwater water park. Sure, you plug it in and it might work for a few minutes, but it's fundamentally doomed by design.
It's worse than doomed, actually, because it's not just getting splashed. It is entering an active chemical battleground. The marine environment is just brutal.
How bad are we talking?
We're talking about constant saltwater exposure, extremely high humidity, relentless vibration from the engines and the waves.
Right, the boat is basically a giant drum.
Exactly. Plus UV radiation beating down from the sun and wild temperature fluctuations. Automotive equipment simply lacks the engineering countermeasures to survive that kind of abuse.
What actually happens when that standard car stereo meets the ocean? Because it's not just about, getting a little wet. How does salt spray actually destroy a standard circuit board?
Well, salt water is a highly conductive, highly corrosive soup. When salt spray or even just heavy salty humidity settles onto a standard circuit board, the salt basically acts as an electrolyte.
Okay, so it conducts electricity.
Right. And if that board has any electrical current running through it, and I mean even just standby power like the clock on the radio, you trigger galvanic corrosion.
Oh, wow.
Yeah, it's essentially creating a tiny, incredibly destructive battery right on the surface of the electronics. The electrical current literally eats away the copper traces on the board.
Just eats it alive.
Completely. And this isn't something that takes years either. It can happen in a matter of days. Furthermore, the salt bridges the microscopic gaps between components, which causes immediate, fatal short circuits.
So buying the cheap car stereo actually costs you more because you'll be ripping it out and replacing it halfway through the summer when it shorts out.
You are absolutely guaranteed a premature failure. And that is exactly why Fusion Marine radios are engineered from the ground up for this specific abuse.
But what do they do differently?
The internal components are completely sealed off. The circuit boards receive specialized conformal coatings.
What's that?
It's a microscopic layer of protective polymer that's baked on to resist that exact galvanic corrosion we just talked about. Plus, the connectors are heavily waterproofed to stop moisture from wicking down the wiring harness.
And the speakers themselves are different too, right?
Yeah, completely different. The cones and the baskets are manufactured from highly specialized UV-resistant materials.
Because, I mean, if you put a standard plastic car speaker in the Florida sun, the UV radiation physically breaks down the molecular bonds of the plastic.
It just turns it totally brittle.
Right. So the first time a heavy bass note hits, that cheap speaker cone will literally shatter into pieces.
Exactly the case. So once you've built this bunker of a system that can actually survive the water, the salt, and the sun, a completely new problem emerges.
Which is?
Surviving the elements doesn't mean it actually sounds good.
Oh, right.
Which brings us to the acoustic architecture, how the audio is actually distributed and processed in a totally open-air environment. Rebelio's guide spends a ton of time on multi-zone audio control.
Okay, so let's look at a typical vessel for you guys listening. You've got the helm where the captain is navigating, the cockpit where people are hanging out, the bow up front, maybe a salon inside, the cabins down below, and maybe a flybridge up top.
That's a lot of distinct areas, and if you try to control all of those zones with just one master volume knob, you have created an incredibly frustrating environment for everyone on board.
Wait, but setting up 6 distinct audio zones sounds like an absolute headache to install and manage. Why can't a captain just buy 2 massive high-powered PA speakers, bolt them to the center console, and just crank up the volume so everybody from the bow to the stern can hear it?
Honestly, it's the most common DIY mistake we see, and it creates an absolute acoustic nightmare based purely on the physics of sound.
How so?
Sound operates on the inverse square law. As sound travels away from the source, it loses energy exponentially.
Okay, so to get the music loud enough for the people relaxing way up at the bow.
Right, to hear it clearly over the wind and the waves, the people standing right next to those massive speakers in the cockpit are going to be absolutely deafened.
Oh, that sounds awful.
It is. You get terribly uneven sound coverage. Plus, by pushing those central amplifiers and speakers to their absolute physical limits just to throw the sound across the boat, you introduce massive, massive distortion.
So the people at the bow hear a muffled, distorted mess,
Yeah.
and the people in the cockpit just have their eardrums blown out.
Exactly. Independent zones solve this. You need independent volume, source selection, and equalizer presets for each specific area so guests aren't disturbed.
Oh, that makes sense. So the captain at the helm can have the volume dialed low to hear the VHF radio and monitor engine alarms.
Yeah, while the people on the flybridge are blasting a party playlist, and the cabin below is playing, soft acoustic music.
All at the same time. That level of customization leads right into the other magic trick the guide highlights, which is digital signal processing, or DSP. Now, a lot of people think DSP is just like a fancy digital equalizer, just bumping up the bass or the treble.
Well, yeah, that's a huge misconception. DSP is much more like having an invisible sound engineer on board making real-time mathematical corrections.
Real time, like as the song is playing.
Exactly. See, a standard radio blindly sends a full-range audio signal to a speaker. But say that's a small 4-inch speaker. It physically cannot reproduce a low 40 hertz bass note.
The cone just isn't big enough to push that much air.
Right. But a normal stereo sends that massive bass power anyway, which the speaker can't convert into sound. So instead, it converts that power into heat, turning the speaker's voice coil into a space heater until it distorts or just melts entirely.
Yikes. But the Fusion DSP knows exactly what it's connected to.
Exactly. The DSP optimizes the audio based on the exact specifications of the Fusion speakers installed, the amplifier configuration, and the specific listening environment.
Wait, how does it know all that?
It literally holds a mathematical model of the speaker's physical excursion limits and its thermal thresholds. It calculates the frequencies and mathematically shaves off that 40 hertz note milliseconds before it even leaves the amplifier.
Wow, so it's protecting the hardware while simultaneously tuning the room.
It really is. The guide notes that proper DSP configuration completely removes the need for the owner to manually fiddle with equalizers. It instantly improves vocal clarity, tightens the bass response, and creates a perfectly balanced sound environment.
Because it stops the speakers from trying to do things they physically cannot do.
Exactly. But here's the catch: perfect sound requires a massive amount of energy.
Which brings up the unseen foundation of this entire ecosystem, right? Power management.
Yes. If you don't respect the electrical demands of these multi-zone DSP processors and massive amplifiers, you aren't just going to get bad audio, you are going to compromise the entire vessel.
Buying a top-tier Fusion stereo system, but using undersized wiring or a weak battery, is basically like buying a high-performance, twin-turbo sports car engine, and then trying to run it by feeding it fuel through a little plastic drinking straw.
That is the perfect analogy. It's going to starve and sputter.
But why do boat owners so frequently overlook the vessel's battery capacity when they are dropping, thousands of dollars on an audio upgrade?
Because batteries and heavy-gauge copper wires are invisible. They hide down in the bilge and under the deck. You can show off a beautiful set of illuminated tower speakers to your friends at the sandbar, but you can't show off an upgraded alternator.
Right. Nobody says, hey man, check out my zero-gauge power cable.
Exactly. But a professional marine installation has to evaluate a staggering number of variables. We're talking about total battery bank capacity, the output of the charging systems, shore power capabilities, inverter capacity, and crucially, cable sizing to prevent voltage drop.
Voltage drop is a huge deal on a boat, isn't it?
Massive. A 12-volt electrical system is incredibly sensitive to distance.
Because 12 volts isn't a lot of pressure to push that power.
Right. So if you send 12 volts down a cheap, thin wire across a 40-foot boat to reach a subwoofer amplifier up front, by the time the electricity reaches that amp, it might have dropped to 10.5 volts just due to the resistance in the wire.
And that amplifier is now starving for power.
Yes. And starving an amplifier doesn't just make the music quieter.
Right, it actually damages things, doesn't it?
Heavily. Starving an amp causes it to quote-unquote clip the audio signal. Instead of sending smooth sound waves to the speakers, it sends jagged, square waves.
Square waves?
Yeah, and those square waves will physically tear apart the suspension of the speaker over time. Furthermore, ignoring power management leads to catastrophic battery drain, random equipment shutdowns, and drastically shortens the lifespan of your incredibly expensive marine batteries.
The guide specifically calls out the mistake of incorrect amplifier sizing, too.
Yeah.
I guess people just buy the biggest, highest wattage amplifier they can find, assuming bigger is inherently better.
Oh yeah, all the time. But that demonstrates a complete misunderstanding of how the audio ecosystem works.
Oh, so?
If you drop a massive amplifier into a tight, unventilated compartment without accounting for heat dissipation or the power handling of the speakers or the battery's ability to actually feed it, you don't get better sound.
You just get a space heater again.
You get a system that overheats, clips the audio, and potentially damages the vessel's foundational electrical infrastructure. It has to be architecturally balanced from the battery to the speaker cone.
Okay, so let's assume we've balanced it. The power foundation is rock solid, the audio is mathematically perfected by the DSP, and the zones are set. Once this level of engineering is achieved, the system's role shifts dramatically, doesn't it?
It really does. It goes from being a standalone entertainment device to a fully integrated node on the vessel's larger network.
The connected boat.
Yes. This represents a major shift in modern marine architecture. A fusion system isn't an island anymore. It's designed to integrate flawlessly with modern marine electronics, specifically Garmin multifunction displays.
Okay, so what does that actually look like for the captain?
A captain can change the audio sources, skip tracks, and adjust the volume of all those different zones directly from the exact same Garmin glass screen they are using to monitor radar, depth, and GPS charts.
Wait, I'm going to push back on that.
Yeah.
Linking a luxury stereo to a critical Garmin navigation screen sounds like a terrible idea. Doesn't that just invite the captain to accidentally mute a shallow water depth warning while they're trying to, skip a Jimmy Buffett song? Doesn't this overcomplicate the helm?
It sounds totally counterintuitive, I know, but the reality is the exact opposite. A unified interface actually reduces helm clutter and significantly lowers the cognitive load for the captain.
Really? Just by combining it?
Think about it. Instead of having 5 different glowing screens, 10 different control pads, and a mess of wires for various independent systems all fighting for your attention, everything is centralized into an intuitive touchscreen interface.
Okay, I can see how this clutter is safer.
And this centralization is made entirely possible by the NMEA 2000 network.
NMEA 2000. Yeah, the Robilio guide treats this like the holy grail of marine integration. What exactly is it?
So before NMEA 2000, boats used point-to-point wiring. Every single gauge, sensor, and radio needed its own dedicated copper wire running all the way back to the helm.
Oh man, so you'd have a trunk of wires the size of your arm running through the boat.
Exactly. It was a nightmare to build and worse to fix. NMEA 2000 is a CAN bus network. It's essentially a single backbone cable running through the vessel.
Just one cable?
One main data cable, yeah. Devices simply tap into this backbone. It acts as a translator, taking different languages from different devices and turning them into one unified digital data stream.
So the stereo just sends a tiny data packet onto the backbone saying, Hey, I'm the radio, lower the volume in zone 2, and the Garmin screen reads it and makes it happen.
Exactly. The benefits are massive for the marine industry. You have seamless centralized control, a massive reduction in the physical weight and complexity of the wiring harnesses, fewer points of failure, and it makes troubleshooting infinitely easier for technicians.
And it's not just the helm tied into this network either. The wireless control aspect is huge. The guide mentions Bluetooth, Apple AirPlay, and being able to control the entire system via smartphones, tablets, or even Garmin smartwatches.
Yeah, the smartwatch integration is incredible.
You could be hanging out on the bow or cooking down on the galley and just tap your wrist to turn down the flybridge volume without ever walking back to the helm.
It's all about convenience. And looking to the future of marine entertainment, this integration is only getting deeper. Entertainment systems are actively linking with ambient lighting controls, vessel monitoring systems, and digital switching.
Digital switching, like controlling the boat's breakers from a screen.
Yes. So imagine this. You hit a quote-unquote party mode button on your watch, and the NMEA 2000 network tells the fusion system to raise the volume, tells the lighting controller to sync the deck lights to the beat of the music, and tells the digital switches to power up the underwater lights.
Oh, wow. So the music, the lights, the environment, all syncing up seamlessly.
Everything talking to everything else.
Which is incredible to think about. But getting a CAN bus network to communicate seamlessly across a fiberglass hull, alongside massive power cables and DSP processors, requires serious human expertise. I mean, theory is great, but pulling this off in the real world is a different beast entirely.
Oh, absolutely.
Which brings us to the professionals doing the actual work and how owners protect this massive investment once it's on the water.
Right. And the source material from Concord Marine Electronics provides invaluable context here. Making these complex systems work inside a boat is an exercise in extreme physical problem solving.
Definitely. For those listening, Concord Marine Electronics is located in Fort Lauderdale, conveniently right inside Safe Harbor at the Lauderdale Marine Center. The guide notes their stellar reputation. They've got over 192 five-star Google reviews and 247 support.
But reading the actual customer reviews is what brings the reality of this job to life.
Yeah, they talk about specific technicians by name. Like, there's Rich Hoglavina, a tech with 25 years of experience. One review praised Rich for tackling this, quote, dirty disaster of wiring hidden under the helm of a 68-foot Princess yacht.
See, a boat isn't built with perfectly square drywall and easy-to-access conduits like a residential home, running a stiff, heavy-gauge 10 power wire, which, by the way, is almost as thick as a garden hose.
Jeez, really?
Yeah. Running that from an engine room battery bank to a stateroom amplifier, without drilling through a critical structural bulkhead and compromising the hull's integrity, takes immense experience.
I bet. Other technicians get called out in the reviews too, Kenny, Mike, Brian, Kevin. It really illustrates how meticulous and physically demanding the reality of this job is.
They are literally contorting themselves into tiny fiberglass compartments just to ensure perfect data connections.
And once those guys get the architecture installed perfectly, the long-term maintenance immediately becomes the owner's responsibility.
Right, the care and feeding of your fusion system.
The guide lays out some essential maintenance practices. It sounds basic, but they stress cleaning the equipment using only soft microfiber cloths and fresh water.
They are incredibly strict about this for a reason. Absolutely no high-pressure water, avoid all abrasive cleaners, and never, ever use solvents.
Because a chemical solvent or an abrasive cleaner will immediately strip off the anti-glare coatings on the screens and those protective UV coatings on the speaker grills that we talked about earlier. You're basically unbunkering the bunker.
Precisely. And high-pressure water from a washdown hose can physically force moisture past the precision rubber seals of the radio faceplate.
You might think you're just blasting the salt off, but you're actually injecting water directly into the internal circuitry.
Exactly. The guide also mentions inspecting the wiring annually for any signs of that galvanic corrosion we discussed, and making sure you continuously update the firmware.
Software updates on a boat radio.
Always. Those updates patch security vulnerabilities and ensure the stereo keeps communicating perfectly with the ever-updating Garmin screens on that NMEA 2000 network.
So I have a very practical question for you, considering the listener who might only take their boat out a few months out of the year. What is the single most destructive thing that happens to these systems while the boat is just sitting idle in off-season storage? You'd think sitting still would be safe.
You'd think so, but no. The silent killer in storage is trapped moisture. When a boat sits completely idle, wrapped up or closed tightly, the air inside gets incredibly stagnant. Humidity builds up rapidly inside the consoles, the bilges, and the cabins.
And it has nowhere to go.
Right. So over the months, that heavy moisture condenses directly onto the electronics. The guide is very clear. You must ensure all compartments are properly ventilated. And crucially, you also need to physically disconnect the batteries.
Why physically disconnect them?
If a battery bank is left connected and slowly drains to absolute zero over the winter months due to standby power draw from the radio or sensors, it permanently ruins the chemical structure of those batteries.
And as we discussed, without that power foundation, the entire ecosystem collapses.
It's all connected.
So what does this all mean for you, the listener, navigating your own technical challenges? Let's try and bring this all together. The core takeaway here is that a premium marine audio system like a modern Fusion setup is absolutely not an isolated accessory.
Not at all.
You don't just screw a couple of speakers into the fiberglass and hit play. It is a highly complex, interconnected ecosystem. It requires expert architectural design, precise electrical power management so you don't starve the vessel, and deep acoustic calibration through DSP to actually survive the elements and sound incredible at sea.
And stepping back from the marine industry for a second, these insights about integrating complex technology in harsh environments apply far beyond just boating.
Oh, for sure.
Whether you're researching off-grid solar setups, aerospace engineering, or designing resilient smart home architecture, the fundamental principles remain identical. The hostility of the environment dictates the engineering countermeasures. The power foundation dictates the ultimate performance limits. And the human interface, how intuitively you can actually control all of that underlying complexity, dictates the practical value of the entire system.
It's all about systems thinking. And it leaves me with one final lingering question for you to ponder on your own. As these marine entertainment systems become completely unified with a vessel's navigation, its ambient lighting, and its voice assistance, what happens when artificial intelligence steps in to actively manage the mood, the acoustics, and the power consumption of the boat based on real-time weather and the ocean's behavior?
That's a wild thought.
Right. Like if an AI senses an incoming storm on the radar, does it automatically dim the lights, mute the audio, and redirect all battery power to the bilge pumps and navigation thrusters?
It very well could.
Will the boat of the future play the ocean, or will the ocean play the boat? It really makes you think about that controlled living room from the beginning. You can master the living room, but on the water, you are always dancing with an environment you can never fully tame. Thank you for joining us on this custom deep dive. Keep asking questions, keep exploring, and we will catch you next time.